Welcome again. We are at the O'Hare Airport, and this time we will solve a problem called multi-period work programming. You may remember that in this airport we have a car rental office. Given that the influx of customers differs according to the time of day, it is necessary to have a different number of employees depending on the demand. But just as the demand varies according to the time of day, the demand also varies according to the season of the year. For instance, during academic recess, the influx of customers increases, and therefore, extra staffing must be added in several months. We regularly have two types of employees: qualified personnel, and personnel receiving training. Come with me to the offices, where I will explain with further detail. This is one of our offices for customer service, and the employees behind the desk have already received training. Besides, we have other offices where the new personnel are trained. The training of the new employees lasts 1 month, and the training is provided by the personnel that works for us. And as you may assume, the time they spend in this task is part of their working hours. Now, come with me to the office to show you the most relevant data. Good. Here we are. This is the quantity of labor hours we need for the following 6 months. Each employee works 160 hours per month and is paid a salary of $3,000. The new employees during training are paid $1,500. The employees that are laid off by the company receive a compensation of $2,000. If one of our employees is responsible for training the new personnel, he must dedicate 60 hours of his time to teaching, and he will be in charge of 3 apprentices. Currently we have 100 employees. As usual, the first step in formulating the problem is to define the decision variables. When we do this, it is important to imagine the decisions we must make. In this case, our decisions should be the following. How many workers will spend all of their time servicing customers? How many employees will spend part of their time training new employees? How many apprentices must be hired? Or else, how many employees must be laid off? If you think using these concepts, it is easy to imagine which will be our decision variables. The objective is to minimize the costs. These costs are the salaries of the employees, layoff compensations, and the new hirings. Therefore, our objective function is the following. Now, let us consider the constraints for the first month. Try to explain each one of these expressions. The first expression means that the number of employees that will work with us during the first month, plus the number of employees that will be laid off, must add up to 100 employees. The second expression says that for each 3 new employees, we must have at least 1 trained person to offer the training for the new employees. The third constraint says that the number of hours dedicated to our customers must be at least 8,000. In this case, our employees that are not in charge of training activities must contribute 160 hours to this task, while the employees in charge of training must contribute 100 hours to customer service. As you can see, there are no more constraints in the first time period. Now we will define the constraints for the second period. As you can observe, with the exception of the first constraint, the expressions are very similar. The purpose of the first constraint is to define how many employees are found in the company at the end of period 1, and to specify that the same employees will be available at the beginning of period 2. In this equation, it is necessary to understand that the workers found at the beginning of this period are those who were not laid off at the beginning of the previous period, plus the new employees. The other 2 constraints in this period have the same meaning as those which appear in the first set of constraints. The constraints for the third period are the same as the ones for the second period, but with different subindex. Since we already know how to represent the constraints of each period, allow me to present the complete formulation of the problem. The solution is as follows. After we have solved the timetable programming problem and the multi-period inventory problem, I hope this formulation has been easier to understand. Well, I will see you soon.